prepared in both thin film as well as bulk form. So as far as thin films are concerned, I have investigated chalcogenide materials and metal oxides. This is not a broad classification of materials in thin film form or materials in bulk form. This is the classification of the research work which I am carrying out at Deposition. So as far as chalcogenides are concerned, we have used them in PEC cell. As far as metal oxides are concerned, we have used them in transparent conducting oxide, sensors, catalysis. Bulk material which I have investigated, they include ferrites and metal oxides again, and these were used for MB composite, sensors and catalysis. So one thing which I would like to mention here is that the thin films which I have investigated, which I have prepared for various applications, all these films were prepared with the help of spray paralysis technique, which I am going to explain. Here I have summarized my research. I have worked on a variety of materials, which you can see. There are oxides, there are chalcogenides, mainly they are oxides, and on this axis number of publications. So I have published most number of papers on zinc oxide material, which is transparent conducting oxides, and I have used them for these zinc oxide thin films for various applications. For the contribution, as mentioned by Madam, for the contribution of my research work, recently I was honored by the Maharashtra Academy of Sciences. They have given me the life membership of Maharashtra Academy of Sciences. So, to begin with, what is thin film? So, thin film is the material which is restricted in third dimension. It has length, it has breadth, but its thickness or the third dimension, it is restricted. It is restricted to some value, thickness. Generally, if the thickness of your material is less than 1 micron or so, then we call that material as a thin film. So let me tell you the materials which we come across in day-to-day life. For example, acrylic boards, brass boards or sheets, their size is of the order of 1 millimeter. The thick film, which we prepare with the help of screen painting or gold or aluminum foil, the thickness is of the order of 10 to the power of 3 mm. 1 by 10 to the power of 3 mm, 10 to the power of minus 3 mm. And if the thickness is less than 1 micrometer, this is 1 micrometer, that is called as thin film. So here you can imagine the film which has length and breadth, but its third dimension. If it is less than 1 micrometer, then we call it as a thin film. How small this thickness would be? We can ask this question to ourselves: how this thickness, less this thickness would be, minimum this thickness would be. The minimum thickness which we can achieve in thin film form is of the order of dimension, etc. The minimum thickness is the 1 atomic layer. Let me tell you the fact that what happens if we decrease the thickness of the material. When we go from bulk to thin film, the property changes. Why they changes? One example I will explain, and you can imagine what would have been happening or what would be happening in other properties as far as the material when we bring its third dimension down. If you consider the formation of bands in solid, what we imagine? We imagine initially 2 isolated atoms. These atoms, they have their own energy levels. These energy levels, 1s, 2s, 2p, electrons are supposed to move in the circular as well as in elliptical orbits around the nucleus. So when 2 such atoms they are brought together, they are brought very near to each other. And the distance between these 2 atoms is very, very small, of the order of say nanometer or 10 nanometer or 100 nanometer. So what happens? The electrons in the respective orbits of these 2 atoms, for example, electrons in one s cell of first atom and electrons in one s cell of other atom, they start to, or their quantum wave functions, they start to overlap. What do we mean by this? We mean by this, the quantum wave function is defined for the position of an electron at that particular time, at that distance. So they start overlapping, means probability of finding electrons in at those distances, at the respective distances, on the electronic band structure the band of 2 energy states. If you bring instead of 2 atoms, 10 atoms, 100 atoms. So these when 100 atoms or 1000 atoms of this solid they are brought together, then the 1 s electrons of all these 1000 atoms, all these electrons they behave similarly. They behave in a group. Their quantum wave function, they get lost with each other. And this band is formed. We call the outermost orbit or the band formed by the electrons in the outermost orbit as a valence band. The next band is the conduction band. The distance between these 2 bands, we call it as a band. So what happens when there are 1000 atoms with you? What happens when there are only 10 atoms with you? So if you decrease the thickness of the material, then the distance between, as the width of the band goes on decreasing, as you increase the number of atoms, the difference between valence band age and conduction band age increases. That is the reason why, if you decrease the thickness of a material, the band gap of a material increases. This we call as a quantum size effect or band gap widening. So this is one property. If you decrease the thickness of the material, similar is the case of resistivity. Similar is the case of other properties. So we cannot go behind the 1 atom. This is the minimum, and that is called as it is a well-known 2-dimensional structure, 2D structure. In the material science, it is called as 2D. Of course, there are 1-dimensional quantum dots also. So these thin films, which were prepared with the help of spray paralysis technique, they were used in solar cells. We are using them in solar cell. Transparent conducting oxide. What this transparent conducting oxide is, I am going to tell. Then gas sensor, UV detector, and photocatalysis. Photocatalysis is the acceleration of chemical reaction with the help of catalysis. So these films, they are used as a catalysis. They are used for water purification. This is one of the applications. That also can be explained, but in a separate lecture. TCO, transparent conducting oxide. Let me take your some time for explaining this transparent conducting oxide and what these transparent conducting oxides are. Because